and respected Professor Kallol K said, our MSc students, on behalf of Department of Chemistry, I welcome you all for a special lecture today, which is going to deliver by Professor Kallol K. But before going to start our lecture, আমাদের বিশ্ববিদ্যালয়ের রীতি অনুযায়ী লোকমাতা রানী রাসমণির প্রতিকৃতিতে মাল্যদান ও ছোট্ট চারাগাছে জলসিঞ্চন করে আমরা যে কোনো অনুষ্ঠান শুরু করি। মে আই হাম্বলি রিকোয়েস্ট ইউ আমাদের যিনি our honorable vice chancellor sir, Professor Kallol K sir, registrar sir and PG secretary sir to do the
ছাত্রদের মধ্যে কেউ এসো কোথায় স্যার ওদেরকে ধরো কি করতে হবে আর কেউ ওগুলো নিয়ে থাকতে হবে। আচ্ছা স্যার একটু বাড়ি সিঞ্চন জল দেওয়া না আর দিয়ে দিন কি বলুন এরপরে কি করবো আমরা?
Now we felicitate Professor Kallol K sir by Victoria. I request our student showing
secretary sir.
PG secretary sir.
PG secretary sir আপনি ভিডিও দিয়ে এটা আপনার ডিপার্টমেন্টের প্রোগ্রাম ক্লাস মানে স্পেশাল লেসন না ভিডিওটা দিয়ে স্যার একটু ঘুরে চেক করে এরপরে রেজিস্টার স্যার ধন্যবাদ অতীত স্যার আপনি দেবেন আমরা কেউ নই।
Now I request our registrar sir to
আপনি দিন না আপনি রিড করে দিন। হ্যাঁ
This is a appreciation from our university, token of appreciation, appreciated for your excellent presentation in the form of special lecture by Professor Kallol K, distinguished professor, School of Studies in Chemistry, Pandit Ravi Shankar Shukla University. Dated 29th May, signed by our honorable
অনেক বড় বড় প্রোগ্রাম করিয়েছেন না
এবারে আর কিছু না আমরা চলে যাব আপনি স্যারকে ফর্মালি ইন্ট্রোডিউস করুন স্যার উইথ ইওর কাইন্ড পারমিশন এবারে নাও পড়িয়ে দিন স্যারকে ইন্ট্রোডিউস স্যার আমরা চলে
PQC we are very honored that we have sir has come from Chhattisgarh. Actually he was distinguished professor of Pandit Ravi Shankar Shukla University. There he was Dean of Faculty Science and member of Executive Council of the same university. I am associated with sir from long ago, 2017, when I was delivering a lecture in Amarwantak Central University. So first time there I have met sir. Sir was also there. Dr. Ghosh obtained his PhD degree in 1986. He carried out his postdoctoral research on artificial syntiophores in an INSA JSPS visiting fellow in the laboratory of Professor Akira Kota at Seiki University, Tokyo, Japan. and he was also a James Chair Visiting Fellow at St. Francis Xavier University, Antigonish, Canada. Sir has received several prestigious awards, including the Bronze Medal of Chemical Research Society of India, CSRI Bangalore, and Sir also has received the Professor B.N. Ghosh Award of Indian Chemical Society, Kolkata. Dr. Ghosh has published more than 240 research papers in reputed journal and international journal, and he has supervised 34 PhD students, scholars to successful completion, and some of his students has got position in throughout the country of our country. Dr. Ghosh is currently serving as Joint Secretary of Chemical Research Society of India, CRSI Bangalore. He is the Vice President of Indian Chemical Society and Indian Society of Surface Science and Technology. Just few months ago, we have organized one day seminar. So that seminar was also supported by Sir's contribution. Dr. Ghosh has represented India on numerous international platforms and visited several countries including USA, Japan, France, Netherlands, Singapore, Croatia, Thailand, Malaysia, Spain and Canada for academic collaboration, conference and lecture. His career reflects a sustained commitment to excellence in teaching, research and scientific leadership in the field of chemistry. His major research interests include function and nanomaterials, detoxification of stimulants, of chemical warfare agents, development of novel reactivators, micellar catalysts, micellar enzymology, surfactants and surfactant protein interactions and ionic liquids. So may I humbly request Chair to deliver your lecture, and you all please listen his lecture.
I'm not talking about the recording.
Sir,
Yes, please. So good afternoon. I give it a great pleasure and honor to be part of this very important lecture organized by that Rani Rashmoni University, Singur. And I have no word to express my deep sense of gratitude to my old friend, Professor Kumar Panda, and of course my another, I should say, very brilliant student, Dr. Pratik Majhi, for giving me this golden opportunity to interact with the MSc student. Actually, I was here because my native place is called Kolkata. So I am just during my summer vacation, I received a telephone call from him and I received the course content. So I accepted your invitation. And for last 40 years, I have been teaching various aspects. Basically, I am a physical chemist. And I must, before I start my discussion, because very few students are here. In our university, first semester students is 60. And total is more than 100. It's a very big seminar hall. So I just want to know how many students are, because my topic is related to MSc course semester. But don't consider it as a lecture. It is one type of research-oriented discussion. So how many students are from actually fourth semester physical chemistry? All are? Yes. Second semester. All are second semester. How many courses?
9 students.
9 students. So don't worry. Very simple topic. Now you know that you must know that from where I am coming. You know that there is a new state that is called Chhattisgarh. You might have heard about the Chhattisgarh. And Raipur is the capital city. And our university is a very old university, one of the oldest and biggest, 62 years university. And most important is that our university is A+ university. And it is a research-oriented university. Because you know that during the last 5 years, we acquired around 21 crores of rupees for the research. And I belong to the chemistry department, which is one of the best departments in our country. And that is related to DSP PARS, UGC. Gradually you will understand what is PARS, performance of the university research for scientific excellence. And there are a large number of equipment. I will not discuss about all these things. Now, you know that nowadays people are working on the various fields. At present, I am working on the functional materials, and you know that everybody is working on the MOF and nanomaterials. But I started my career as a chemical kineticist. So therefore, I thought that I must discuss something about that. Now, and because I have received a telephone call and I don't have that time the laptop, so I have prepared very hurriedly that lecture. But I have prepared at least 120 video lectures for our students at the National Institute. So if you have any doubt regarding this 4th semester course, you can go all these my video lectures. Now, when I have received this Rashmoni University's prospectus, 4th semester, particularly chemical kinetics, I have seen it is also useful for the MSc first second semester students. That now you know that as per the national education policy, the whole teaching system has been changed, completely changed, and it is based on the conceptual understanding. If you I do not know whether you are appearing in any interview, you involved in UPSC or PSC or college service commission. So concept is very important. So I have seen that before going any subject, whether it be inorganic or organic or physical, you must see that what you have to study. So key courses. I have seen that your course composed of 3 important parts. One is fast reaction, which is very important. I will not discuss today fast reaction. Another is the unimolecular reactions. And third is the dynamics of molecular reaction. That is called the molecular reaction dynamics. Today what I am thinking, I will discuss only on the unimolecular theory and the reaction. And you know that it is very difficult because classroom teaching is different, and within 1 hour or 2 hours to cover whole unimolecular reaction is absolutely impossible. But what I am trying to do here, I will discuss some of these fundamental points, just like storytelling. Storytelling about the unimolecular reaction. And I will discuss from first method to the last method, ultimately. So, that is my objective. Secondly, now if I ask you, do you know what is the fastest reaction? That is the simple formation of the water. And you will be happy, glad to know that 3 scientists were awarded Nobel Prize that year. So before starting any subject, you must know that what is the importance of that reaction. Similarly, now from school level, because I am talking about unimolecular reaction, so name itself is a definition. A plus B is converted into C is a bimolecular reaction, and there is a collision. But suppose there is only one molecule, so it is $1 million question, how that molecules acquired energy. And you all know school level hydrogen atom and hydrogen molecule reactions. You know who was awarded Nobel Prize for that simple reaction? At the age of 83, Martin Karplas. I was not aware of your course content. We do teach in our university. But application is very important. That how that simple hydrogen and atom and hydrogen molecule reaction actually the protein structure that gentleman was. So these are some important why we study all this type of things. I will not go into details of all these things. Now I am coming to that why the concept is important. I am taking this information from your course content, which was said by Dr. Prof. that core knowledge is important. If I ask you that derive the Dinsel-Root equation or derive the RRK equation, or in the interview if I ask you, can you write the final equation of RRK theory? But if you understand, I strongly believe that after listening my lecture, you are able to speak, you are able to answer any question related to all these unimolecular theories. That is the beauty of the teaching and beauty of the research oriented. So when you face any interview, the expert will test your core knowledge, your conceptual concept. They will not ask that whether you scanning facility like that. Then analyzing skill. Very recently I have seen that diagram from the chemical review. You see that knowledge, hypothesis, that is the most reflecting thinking and scientific reasoning. And believe me, I am not, because this is new university, don't worry, don't underestimate. They are all good students. All students are equal. But most important thing is that if you blend your research, I will not discuss anything about the research. I belong to the classroom teaching. But I always consider that research-oriented teaching is the most important thing. So that you have a clear-cut idea about what is unimolecular reaction and how we solve all these unimolecular. Now, you may agree with me or not. Now, everybody is working on the chat, GPT or artificial intelligence. But as an old teacher, I always believe that without good books, so my request to all these students that you must refer. There are 2 types of books. Because today we are discussing unimolecular reaction. Naturally, first I will give you some general. It is also useful for the second semester students. I always, when I was a student also, that time also I preferred that Albert and Daniel. And I was so happy when I seen that Louis Bowendi was awarded Nobel Prize for that quantum dot. I was very happy that I have referred a book which is written by Nobel Prize. It's the undergraduate level book. Then Atkins, you all know, wonderful. Then Levine, Castillon, Louis Barrett. Don't worry, I am not talking about very big book. Second, specific book. Because we are dealing with the chemical kinetics and unimolecular reaction. So in addition to that great book, I think you are all aware of this chemical kinetics with KJ lecture. Because most of the derivation is based on this book of the lecture. And there are, if you see the Vice Chancellor chamber, there are a large number of good books are available. Like Fundamentals of the Chemical Kinetics, Kinetics and Mechanism, Frost and Pearson, Robert Taft, and Progress in Chemical Physics. As because I am talking about the research-oriented teaching and unimolecular reactions, so I will also show some of the books related to unimolecular. Because my today's lecture is based on completely unimolecular reactions. You think that from where I get all those books? I do not know that whether your university is related with one nation, one subject. I think maybe. So we can get all these books free of cost to the internet. So these are the best books for the unimolecular. If you have any doubt regarding my topic, unimolecular reaction. Now, I again request, I do not know that whether you are referring or not. There are some very good journals for the chemistry students. You all know that the biggest society is the American Chemical Society. Your Vice Chancellor member, I am also member, and the Royal Society. You are thinking that why I am talking about all these things, I am chemistry students. But after doing this 4th semester, you will attempt for IITs or you will attempt for NET examination, you go for an Indian National Particular Science, or IIT Bangalore. So you need all these type of things. So by that, and the language is very simple. Journal of Chemical Education, Chemical Education Research and Practice. If you think, no, I don't want to read this foreign writer books. Tell me some Indian books. Okay, Indian journals, great journals. Regions. I am taking many derivations from those Journal of Chemical Science, with Professor Sattapurti and various others. This is the motivational type. Now, you all know this great man. This is our university because I am, like your Amyo Panda, I am also involved in such type of public outreach activities. I am the coordinator. I always invite the scientists from various parts of the country. To invite Singur with the India's best quantum chemist. And there is a blackboard and he just write the Schrodinger's equation, particularly walk. Excellent day. We have invited Sattapurti, another physical chemist, who started in our country in molecular reaction dynamics. He then got director. And you all know that Compound Bhattacharya, director of the Indian Association of Particle Science, ultra fast. So I listened to them, K. Ganesh, you all know, director of the Isaac University. It's a great scientist. So like that, their lectures are available in the NPTEL, National Program for Technology Enhancement. আমরা ছোট ইউনিভার্সিটিতে কাজ করছো কিন্তু আমাদেরও ভাবতে হবে যে না আমাদেরও টার্গেট মাস্ট বি ভেরি হাই, রাইট? So after this introduction part, now I am coming to my topic. Why first thing is that as per the National Education Policy, there is a program outcome, course outcome, program specific outcome. Why we are studying? If you ask me that, I started my career as a lecturer in 1987. That time there was no concept of the molecular reaction dynamics. But now after 40 years, what I learned, that whole chemical kinetics is nothing but the story of 110 years. How? From the school level, I think class 7 or 8, everybody is learning the great equation that is called the Arrhenius equation. Today I will derive when I will see that when I derive the RRKN theory, still I will use that great scientist who was awarded Nobel Prize in 1992. You cannot forget whether yes, you studied in the school level. But if I ask you, can anybody can tell me what is the formula of the Arrhenius equation? And then when I just joined as a lecturer, before that I completed my research, I was not knowing that what is happening in the molecular world. What is happening in the molecular? So it is a transformation. Unimolecular A is converting to B. So there are some theories underlying principles that govern the properties and behavior of that compound. How do I know? There is no technique. But thanks to the great scientists, the heart, ESB, Hartberg, Rani, awarded Nobel Prize for molecular reaction dynamics. Now everything is clear. Everything molecular. So after that I must salute this scientist. And if I ask you, anybody, have you heard about the TSS, transition state spectroscopy? Anybody? What is it? In the transition state, will it be possible for us to determine the transition state? No, but yes, that is possible, and that course is called TSS, transition state spectroscopy or femtochemistry. And again, Nobel laureate Annabel Well, California Institute of Physics. So this is the story. So my title is Story of Unimolecular. So, and this and the doing science, then you create the interest. Why you have physical chemistry always boring? In my time, there were only 2 students in physical chemistry. All are doing organic chemistry. But nowadays, if you ask me in our university, there is no division. Whether you are organic chemist or inorganic, you have to learn theory, you have to learn quantum chemistry, spectroscopy, organic synthesis, know everything. No distinction. Also that time I love physics. So that story is here like that. Now I am coming to the unimolecular. Why I am talking research oriented is that time one talk and this chemistry. But if you have any idea about the Nobel Prize, chemistry is no biology. It is here from IIT Bangalore, best. You will also realize now biology mostly. All the biological processes can be studied with the help of it, whether it is material science, whatever it is, quantum dots, everything, quantum confinement, but for the biological. So now I am coming to unimolecular. Why you study? Because it is paramount importance in the fundamental understanding of any type of thing. And who invented this unimolecular theory? Great scientist named Lindemann. Therefore, my title, and in your course is also there, Lindemann theory. He actually started. Lindemann. What was the problem? Problem was that you take a vessel and then only one person, you can ask a person to hold on. But hold on, you have to put the money time. And I am not going to hold on. Not possible. That is one that is going there. Okay, I absorb some infrared radiation. I mean, what radiation? Alright. My personal radiation. That one person, England, Oxford University, Lindemann objected. No, your system is wrong. Then we started second theory. There are only 3 students in the chemical 4 semester. and I am having 100 rupees, and I am giving 30 rupees, you will be happy. But a second semester also there. So then there is a problem. 10 rupees, 10 rupees, 10 rupees. 100 rupees, 5 rupees, 5 rupees, 5 rupees. So how I distribute that among the different energy levels, that was solved by great science, again Nobel Prize. We are very happy that we are talking about the Lindemann to RK, and it is quote to our Nobel. You can understand what is the importance of this field. Now these are all simple. I do not know about the question paper and in our university will be asked. If we are talking about the fast reaction, so first you must know some of the example of the fast. So everywhere you have seen that there is one molecule, sulfonyl chloride or bromine or acetonitrile or dissociation of the nitrogen dioxide, and most importantly isomerization. $1 million many times is not my dialogue, because I am a research oriented teacher. I always read some good research. That is how unimolecular reaction has worked here. That was the fundamental. Let me start. Yes. Journey, I am coming from today South Calcutta to Singur is a very famous place. Then Tarokeshwar, Kanpuri, Journey, but I have seen all these areas. Where in Udri, where in Kanpuri, Sapragachi, and so it is all type of journey. And you enjoy all this journey around. Happy. It is only 40 years journey. In 15 minutes I will derive all these equations. But you see, it was started in 19, so if you read the Marcus biography, beautiful biography published in American Chemical Society, he said that the glorious period of unimolecular reaction, glorious, very on there, and my life at Chapel Hill, North Carolina, son was there. That beautiful university, Chapel Hill, and he has written that my life at Rani Rashmoni University is wonderful. And nice, very hot summer. You are listening my lecture from the Singur. You are also doing that person talking about unimolecular reaction. Then we start with that great Lindemann. Many professors after retirement joined in politics. That Lindemann he also joined with Winston Churchill. He was finance minister of politics. Then we started great man himself, Prof. Then RRK, okay, Rice is the supervisor of that. You see that 1920 to 1952. If I ask me anybody, can you tell me what is the formula of that unimolecular? Or what is the second semester or first semester? What is the formula of transition state theory? PSC question, College Service Commission question. No brain is required. What is this? Very good. What is collision theory? Public Service Commission question. Next question. This is conceptual understanding. Journey. Nothing. You just relate. Del 0, del A, won't mean anything. Yes. Collision number or collision physical. Collision last question. What is activated complex theory or transition theory? What question? School level or 12 level. Concept clear. Anyway, don't worry. I'm not taking any class of the practical examination of the idea. Concept K, he just replace this KB Boltzmann K with T, obviously if you understand the last question, 1952, Marcus, great novel, great, many times visited India. Now my last question is that, what is hierarchy in theory? K again, ABT, Q, well, so that again PSC question, EPSC question, that means all are interrelated. They are brother and sister. Mama to bhai, Krishna to bhai, and all that. But when you see the derivation, you fact. I will see the derivation after. Then what is the hierarchy theory? Hierarchy K activated. So, therefore, concept is you just close your eye, and from today you remember that yes, any PhD or NET or anywhere I can answer very easily. I don't need any complicated derivation. T is my weakness. I always take the T. So now you think there are some new thing. I think second semester maybe get confused. What is that Q? What is Q? Q. Fourth semester. Even E করতে হয়. Anyway, Q is the partition function. Oh, those are partition function and molecular partition function. That means partition function is nothing. How that energy is distributed? আমি একটু তো বললাম যে 4 মে 15 মে 20 মে 100 ছেড়ে আমার কাছে 100 টাকা আছে করে ডিস্ট্রিবিউট will help me. Maxwell Boltzmann. Oh, Fermi. Now I am coming to the last part. So you follow the whole story, and I am going as per your perspective. I am not talking beyond your syllabus. So, Lindman, interlude. Do I make my point clear or not? My language is okay, or I can talk in Bengali, Hindi, Urdu. That is very my language. That is good. Anyway, if you have any problem, like I am taking the, you can ask me. Although it is very difficult in our time, it is difficult for a teacher as well as student. I know not. You can take water and all. Now the final again conclusion. First point is that why we study new molecular reaction? In order to understand the unimolecular rate constant. Okay, in order to understand, everywhere you have seen that K1, K1, K1. What happens when you go for research? Your examiner, your supervisor will ask you, determine K1 experiment. Determine K1 experiment. I think in your MSc practical you are doing some experiment on hydrolysis of methyl acetate or decomposition of hydrogen peroxide. I do not know. Or saponification there. So there must be a match between the theoretical value and experimental. There must be a match between theoretical value and experimental. So you see everywhere, while the technological advancement, there are some problems in the Lindman. I will come to that. Now if you see very carefully, we plot a graph between unimolecular rate constant and the pressure. Let us fall off. That means in lower pressure, there are some problem. Then again Lindemann tried to solve it, but again there is a scattering. If you see the RR theory, scattering are less, and RR chain theory, that means RR chain theory is the ultimate theory. We will start from Lindemann, we will derive Lindemann, very simple derivation I will give you, and then gradually we proceed the RR chain. And the final conclusion is that, and this journey is from South Calcutta to Singur and Tarkeshwar is 50 kilometers. Their story is 32 years, 1920 to 1952. 30 বছর ধরে লেগেছে ওই প্রবলেমটাকে সলভ, যেটা আমরা এখানে 1 ঘন্টার মধ্যে কোশ্চেন লিখতে পারি। তোমরা ভুলে গেলে 5 আর কি হলো ঠিক আছে, বললে আমাকে বলো আই and as you know that I always talk about some history, and I must confess, because first time I am talking in this Rashmoni university, I do not know what about the way of teaching, the way of derivations. I must confess that my derivation, I consider it very simple, but you are free to refer any book, and as per your convenience, as per your university, you derive. Don't rely on me. So in some books it is called as the Lindemann and Christensen. Why? Because same time in 1922 when he derived the equation, another scientist also, অনেক বইতে অনেক প্রসপেক্টাসে অনেক কোশ্চেন আনসারে ডেটাল পলিটিক্যাল পড়াশোনা লেখা থাকে, লিন্ডম্যান ইজ ক্রাইস্টিয়ান ভ্যাকসিন, অনেক সময় লেখা থাকবে লিন্ডম্যান এন্ড হিমসালু মেকানিজম, so all mechanisms are related, so don't get confused. Now as you know that it is my hobby, that whenever I teach any class in my class or university, I always give that discussion. Now because থেকে আমি শুরু করেছিলাম রেডিয়েশন হাইপোথেসিস, আমি একা লোক আমি আমার সাথে ঝগড়া হচ্ছে না, আমি এবারে রেডিয়েশন নিলাম, there was a society that you all know that non-judgmental Faraday society, and you will be happy to know what society say Lindemann, Arnium, Langmuir, and one Indian scientist, Neil Ratan Hall, in our Bengali or Jognath, Vivekanand, Amar Hussain, or if you see the Nobel Prize, 100% from Bengal. Proud of 100%. One great scientist, Perry, who discovered the radiation theory. Only one gentleman, that British physicist, he objected, no sir, your system is wrong. Tell me why my system is wrong. Then he started derivation. Then that is the second theory. I am not discussing it. Now, please, this is the starting point. If you don't understand it, very simple. I need one Kochik Maji for wherever, for collision. So that Kochik Maji is inert gas. In some books, when you go to your home and just you find that sir has written A, but in our letter at M. So that is a bar gas or a inert gas. So there is an energization process. I am taking energy from that T. So there is that process, that collision process, and there is a collision, and there is the activation, there is the start. So that process is called the energized process. But it's very important. There is a time lag. আপনাদের অনেক ঝড়া হল, পাশের বাড়িতে আমরা শুনছি থেমে গেছে আমরা থেমে গেছি তার মানে আবার কিন্তু একটু ঠান্ডা হয়েছে ওদিকে যাবে অনেকক্ষণ ঝগড়া চলে যাবে এরপরে de-energization process and de-energization, not activation. Please don't get confused with activation. And then when it just energizes, then it converted into product P. So that mechanism is for Lindemann and Hinselberg. Okay, there are four theory. Lindemann, Hinselberg follows this mechanism. Now RRK. Okay, rice, gas burger, gas. Three scientists. And one, it is not India. আমি কাজ করলাম আমার নামটা দেখে so great scientists marker to honor their teacher like the quantized speech. There are two photographs in India. One photograph Professor S.P. Maulik, great scientist. Another Professor Ajit Kumar Chakraborty, he is called. So what is the difference between these four mechanisms? First part is same, energized process. Now you can understand what you need. That energization process is not sufficient for conversion of the product. Energization process is not sufficient for conversion. In between energization there is another process that is called the activated process. It's so simple. And RRK theory and RRK theory. So therefore, here is only K1, K2 process. So this is K active. So what RRK did, they clearly distinguish between the energized process and activated process. Do I make my point clear or not? Only that माथा खाना है ठीक है ये बात हम जेल से and you know that in physical chemistry yes elementary mathematics I'm sorry we are going to learn some mathematics communication and graph is very now you see there are three types of E. বাংলা में অনেক সময় হয় যাকে আমরা বলি গুরু চণ্ডালিকা দোষ আমরা বাংলা জানো গুরু চণ্ডালিকা দোষ মানে শুদ্ধ ভাষা আর আমি আজ দক্ষিণ কলিকাতা হইতে নগর বাহান করিয়া চলিয়া না গুরু ভাই আমি আমার ক্যারাম করি आलू भाषा मिक्स वगैरह मुश्किल है तीनटे ही रहे हैं उल्टा गुंजन डाली तो प्लीज एक्सक्यूज मी ताड़ाताड़ी हम लोग गुंजन डाली कर दो देखते हैं देरी है कारण এখানে তিনটে ই আমাকে ডিস্টার্ব করে why because there are three systems I consider the first system is the energized process that is E capital E and another is the activated process that is EX. So these two is different. If E is different, if E is different. Again I must compare that in some group energy can be written as epsilon. हमने अमेरिका को देखे तीन लाइन तो देखे सब उच्चारण अलग है. Eta to the epsilon. But here today I am using everywhere capital E as the energy. Capital E and I am using three. One is normal energy and capital. Another E is very important. That is E zero. What is E zero? Anybody? No. It is the difference between 0 point energy of the reactant and 0 point energy of the activated state. It is called threshold energy or critical energy which is actual responsible for integral transformation. So I think there is no confusion between E activated and E0. Okay? Now I'm coming to the area. 5 minutes I think. Sorry. Now, why I am doing this derivation? Because for all these experiments you can't change with one another. Now please listen very carefully. And that is the magic. Because if you acha eta bolo কেউ এটা কারেক্টলি তুমি আমি তো পড়িয়ে দিই স্যার এটা রিভিউ হয়ে যায় এখন আমি বলতে আসছি পড়ে দিই ইন্টারভিউ করে দিই ইন্টারভিউ আর কি করে দিই যে একটা পড়বে পড়ে নি এটা পড়বে না পাই ভালো স্টার্ট Okay, don't worry. আপনি যেটা আমাকে পাঠিয়েছেন আমি সেই জিনিসটা লিখে দিচ্ছি। No problem. Let me start with this. Very simple. A plus A has you know I am not using here N. You can. Why I am just deriving this? Because if you understand the unimolecular theory, final equation, you can very easily derive all these equations without any problem. But if you don't understand the unimolecular theory, it is very difficult for you to derive all these. I can write what? You know that almost very basic level of electrical steady state approximation. I can write but because we are talking about the unimolecular reaction, so basically in some books it is written like that superscript. Why this equation important? I will tell you. So, what I will do? Apply this state approximation. I have to remove this. You know this. So, I can write like that. Very simple, BSc level. But why this is? So you know that. Minus because this is starting point. That's why I'm just doing all this exercise. Because it is so I can write like that. Okay, 2 minutes. Just please. A1. Substitute this value, I will get this. A2, great. A1 fixed. 20 or 22 like that. You publish this as on the original. The problem was that if the pressure is very high, so that this process, this creative value will be, this is next type of the question. So it can be eliminated is a first order. And that was the starting point of the quarrel. Why such type of thing is happening? And if the pressure is low, it is second order. That is the question. And that RRK and RRK is not. And I am following the book of the lecture. I will book I will. But that is not our objective. Our objective is the determination of the unimolecular rate of. Just keep in your mind that all those theory of reaction rates, in the interview they can ask what is the objective. You will just the objective is that determination of the rate constant accurately. Okay. So in one case rate is that, one case rate is that. So our objective is that P1 is equal to P1 is so K1 is then when they plot a graph between, so therefore I am just first graph is that K1 and A. This is constant. So then why? And there is a mismatch of the theoretical value and experimental. So point is that if I both numerator and denominator is divided by both numerator and denominator. Right there, square one is the final. This is very careful. 1 plus this. So I am getting that this is most important. Or I can write to know this thing by developing it must be a good analysis of reaction circuit. So when they are not getting straight line, they again heat tight. That is why plot a graph between 1 and A, 1 and 1 A. They are not be straight line. That is the failure of fast linearity. Although you have got many recognition, but now after 5 years of that equation, now see very carefully. There are two important terms. One is K1 divided by K inverse, and it is a one type of ratio. Up to 1922, there was no concept of statistical mechanics. Because that K1 and K inverse 1 is the energization process and the de-energization process. কোনোটা ছেলে বলতে আছে কার মাথায় ঘুরছে খাওয়া বা কিছু আছে না ভাই ঠিক আছে স্যার তো আমি বসে শুনি ইটস ভেরি ডিফিকাল্ট ফর মি কি করে জানবেন যে বসে আর ইন্টারপ্রেট করি আই অ্যাপ্লাই সাম ও সায়েন্স ক্যান ইউ আর আমি অ্যাস্ট্রোলজার বুঝতে পারছি এই সব বাত মেনে যে না পারবে আর কোথায় বলতে জানে না। Then another scientist, a very great scientist, that you know that there are 19 molecules and having different, it's very difficult for me how to calculate the energy distribution, average energy, kinetic energy. Thanks to the great scientists, J. Clark, Maxwell and Goldman, all spectroscopy is based on Maxwell, Goldman distribution. All know a very simple equation. So then Lisa thought that how do I calculate this K sun and K inverse and this K and then they apply some math. I will come to that. So what is the demerits of that Riemann theory? For example, what is the demerits of Riemann theory and what is the adjustment of the Singur theory? So demerit is that we are not getting a straight line. That was not a result. Where there is a mismatch between the experimental value and theory. Number two, there is no concept of the energy distribution. So Singur, who is a Nobel laureate, who modified that equation and used a new type of equation. How? Now you know that why I am talking that these theories, this formula is important. Only this important. Why? তখন তোমরা বাড়িতে পড়বে and question নিয়ে ঠিক হবে আমি এক ঘন্টার মধ্যে পুরো চাকরি ডেফিনেশন করতে পারবো না তখন করবো যদি বানিয়ে নিয়ে first point is that you should forget the fundamental why I am just at the solar equation can if I forget the Riemann equation and in examination examiner will ask you to derive the hierarchy. Unable to write. So in Singur root, what we point out. Singur root, I show how I get this formula. That there is a concept of distribution. You all know that this equation is all there. Goldman distribution. Out of 15 students, N0, N there, excited. They are understanding something, other are useless. So there are 3 parts. So he, I am directly aware of that they consider one type of harmonic oscillator. It is modes, 1 bend, 2nd bend, 3rd bend, 4th bend. And there is possibility you can exchange your energy because there is other spectroscopy enhancement which is there. Here there is a vibration energy, transmission energy, rotation energy, electronic energy. But Singur would consider that energy is vibration. That energy is only vibration. So I can write E d I. And degrees of freedom, you know that degrees of freedom. If I ask you that in base level, K root, A component and degrees of freedom. Minimum number of factors, variable, temperature, pressure, that must be seen in order to understand. molecules having vibration, translation, rotation. So in order to understand the structure, we need that. So what is Singur theory? They just replace that K1 divided by K1, and that is 1. মানে এখন ডাইরেক্ট ডিফারেন্স করে বোঝাবো এটাকে। S minus 1 factorial E by KT S minus 1 exponential E by KT 1 by KT. That's the important thing. So what I do, I derive, I ask 1 divided S is the degree of freedom, minus 1 factorial E is the energy, K is the Boltzmann constant, E exponential 1 by K. And now you see that diagram, there are 3 keys, E activated and E0. Don't consider now the E activated. E activated from RRT. Before that, there was no E activated. So don't worry about E activated. But E0 is there. So main Singur contribution is that he actually used that equation and integrate it from critical energy to infinite. Why from E0? Because for completion of that reaction, every molecule has to obtain that critical energy. So up to Lindemann, there is no concept of E0, no concept of the distribution, no concept of the statistical combination. Singur initiated that. Okay. Now, Singur able to derive the difference between this E and E. In some book it is like E0, in some book it is superscript. So please excuse me. हम जो ताज़ा के लिखते E ऊपर लिखे नीचे लिखे इन चारों मध्य देखते तो प्रिपेयर करो। ऊपर का क्या पूछो? अगर इसको हार्ड एंड फास्ट वो जगह रखने वाले E star इधर लिखिए। But you must have a clear cut idea about E and E. So what is the difference between Lindemann and Singur? First difference is that in Lindemann there is a concept of statistical thermodynamics. How energy is distributed, not completely. Number 2, they consider the degrees of freedom. Number 3, they use the Boltzmann distribution. Number 4, there is a clear cut distribution between E and E. So what about the RRK? Anybody? RRK is that they don't worry about the K1 and K1 because Singur is already there. They will concentrate only on the E. They will concentrate only on K2. And again, now the question is that I have 100 rupees. I'm in the other one is master range আছে আমরা মানে একসাথে করতে আর আপনি মানে কোন ধরনের স্ট্যাটিস্টিক্যাল thermodynamics probability most probable distribution and K2 মানে এখন ডাইরেক্ট লিখতে হবে বোঝাবো তোমাকে E minus star divided by E S minus 1 আমি সবাই তোমায় কম করো তোমরা বুঝতে পেরে যাও যে লিমিটটা কি রিজাল্টটা কি RRK কি আর RRK আমি এটা বলে তারপর আমি সিম্পল আমি Singur কি করলো K1 and K inverse মানকে একটা ফর্মুলা লিখে ফর্মুলাটা আমি বলবো the help of Boltzmann distribution and that is formula of the partition function. Vibrational partition function. A omega divided by K. that is called the hydrational partition. Now the distribution process, I need the two physical chemistry understand. I think in second semester or I do not know. In our university, we do partition function. Rotational, vibrational, two important functions. Yeah, partition function. Now distribution is equal. I need the maximum Boltzmann equation and the partition. All are mapping. Okay. Now other. Again there are some problems. Interrogatory problem. We could not solve that thing. After 27, great scientist. I must say that okay, Rice is a very famous scientist. Oscar Rice. Californian. And Castle was working with science and maths together. And Castle another. They are not bothered about the K1 paper, they are bothered about the K2. E minus E star eventually whole and up to Liebman and Hinsaloon, no concept of activated. But in RK, the activated concepts initiated. So that rate constitutes the new type of activity. I will write it. So what you have to do, you have to substitute the value of this and value of A2 and again integration from E0 to E. You will get to final equation. around the program ही देख लो तो आपको जो है अरे सर तो इजी बोल देना Armia equation. What is new? Yes. The last theory, RK. You follow my point, Dr. Prof. Simple language goes down. I am not very clear about it. Students are very near, me student, audience, second semester, first semester, all are very senior man is there. Money officer क्या बोल रहा है? Follow my point. मैं compile कर. Now last theory. You follow my point or not? That what is RK? Nothing. First we will write the Riemann equation. We will substitute the value of K1 and K2 from the different theory. We will substitute the value of K2. I will derive it. And then integrate it. Integrate low pressure and high pressure. High pressure, low pressure, how do you do it? Inactivity. And it is just like your Arminian equation. Therefore, I started my lecture with 1-8. I salute that is Arminian. You follow my point. Great man. And if you heard the lecture of Professor Singur and I can't do. The recent lecture of Professor Singur, we always consider that Arminian equation is data science. In our department, he delivered a lecture on the Arminian equation data science. You wonder what is data science. If you know two rate constant, temperature, you can determine all these activities. So last is that it's RRK theory. Now there is a story. Story is that initial chemistry is Boyer. In terms of mathematics, I am not using mathematics. This is Boyer. Now last verse, what is interesting? This is interesting. Let's say, पूरा chemical analysis का पाँच हमारे साथ ही है। And we say that here, लेकिन अभी complicated पूरे air distributed system है। मतलब हमारा problem है क्या? ये जांच से theory का product से RRK. The story is that Robert Marcus, এটা খুব ইন্টারেস্টিং, আমাদের কিছু থেকে কোশ্চেন আছে মার্কাস was awarded Nobel Prize to electron transfer. So after doing his PhD from California, University of California, he applied for postdoctoral work. One of the postdoctoral PhD for BS, he kind of PhD in 1949, and it was discovered in RRK is discovered in 1927 in India. RRK was discovered in 1927-28. That means when he was okay, right? California University of North Carolina, California, Kallol, beautiful place. Unfortunately or fortunately, he was selected. Marcus was selected as a postdoctoral under the guidance of Rani. I will show you this article. This is what I was telling you about the matter. Mathematics double integration. Then, Rani now shifted to California to that university. And he just start this RRK. There are some problems because in RRK we are not getting this state line. You start this work. And he has given the work of methyl iodide, EHCl. Do it become this? You know what? Marcus was a theoretical thing. Then he started thinking. And if you read his biography, he's asking me, Eureka, so he is not PhD work, he is postdoctoral work. He enjoyed and started his work. And he derived not only K1 and K2, but also K2. And you will be surprised that these formulas entirely different. And it's not going to keep E minus E star when the E is RG. But he discarded it. And he has given a new formula. Very new type of thing. This is a E star N E A. What is this? I mean, how do you think of it? So I E minus E0 discard G E N E A. Take the one. Now I'll explain from where I get it. And K1 and K inverse 1. K1 and K inverse 1 is the probability density. And it is also like the difficult formula K E divided by Q partisan. Very good. I am happy that you so now again you can understand. That is very clear to you. I have to substitute these values in this place and in this place you will return denominator and again integrate it and finally but problem of what is the difference between RRK and RRKM? First difference is that yes, because there are three again and why two times more than three linear order. E0 and E activated. If you E0 to E activated. he or they could not identify the vibrational energy of energized state and vibrational energy of activated state. Number one. Number two, that there is intramolecular energy transfer. There is intramolecular energy transfer. In Arkan theory, he categorically identified the vibrational energy and rotational ER and T. ER and T. In some derivation, some group, this probability density can be divided into two parts. Formula is the same thing. One is for rotational, another is for vibration. Therefore, we need double integration. One integration for rotational, one integration for vibration. That is the concept. And so therefore, the final equation you know that is just like here. ABP, A, capital Q, here, E by R to right. In some groups, this Q is QR, QD you can see. Now, but Marcus is a very famous gentleman. So therefore, in some groups, because if you know the activated complex theory of KBP, delta G, or delta G, delta is minus. So in some books, some research paper, that RRK theory is considered as micro-canonical activated complex theory. What is the difference between micro-canonical and canonical theory? That is if rate constant depends on energy, it is micro-canonical. But in basically, normally what we do, our rate of reaction depends upon the temperature. That is canonical. So it is micro-canonical rate of some group it is recognized as micro-canonical transitional state theory, and we are given full credit to Henry Eyring, the activated complex discovered the activated complex. And to all their students name we ultimately got RRK. Okay, so I will not derive, I will just in 15 minutes I am telling you. Okay, just derivation of program. Any doubt? Then I talk. Difference between two theories.
You said from this semester our department studied physical chemistry acceleration.
Oh, they are not special.
They students are there, but they are absent. But they have interest.
Oh, very good. That by time we made it again. Yes, I got it. ना मेन बात के नहीं ऐसे ये कोई प्रश्न we are teacher and our I am not industrialist and he may be existing at the income and for the corporate social responsibility. Industrialist can donate some money, but teacher what we do? Institutional social responsibility. This is my responsibility. And then you have to interact with this student. You will like it, you will not like it. Not after Sara Dinja.
But second step they have that. They have
I think it will be very limited. Because I am giving a complete picture of that. So just very hurriedly I am going. Every problem is there. Why there is actually why they are doing research, why there is a low concentration, there is fault. That got me. 10 minutes I think. You see. problem started from here. Yeah, these are some examples. First failure of human body. First failure. Any doubt? I am giving some examples that there is a mismatch of theoretical responsibility. I have already talked about reason. Yes, this is without this theory we cannot solve all this. Therefore, I am writing this. So this is the Hinson. So there are different types of, and again you see that I am using that old theory, collision theory. So all are related. Because due to collision, there is a change in internal movement. Yes. Now suppose first level, second level, I can write 1 3 factorial a k cube like that. So you can write directly this. I have just written this. Now here, as I told you that this is the formula of the particular function and
Sorry, sir.
I already created it.
পর্দাটা যা সরিয়ে দাও জানলা খুলো না জানলাটা তো হট
জানলা লক
আপনি লাস্টে একটু এই মুভি বলে দিন
হ্যাঁ কি বলি Now let me summarize the thing. So let me summarize the thing and now the last point is that just 2 minutes. My last point is that we started with the Wingman theory and it was that at high pressure the reaction follows first order kinetics and low pressure reaction follows second order kinetics. And he could not explain this anomaly yet. Then there is no concept of energy. There is no concept of that energy distribution. Secondly, Singur modified that theory using the concept of statistical unbalancing, and he analyzed the distribution of energy among the different modes, energy levels, and he explained the difference between the threshold energy or critical energy and the normal energy. But again there was a problem. You have seen that I am using a Singur equation there is a S, small s, which is called the degrees of freedom, maybe 2, 4, 10 or 20, like that. When they calculated the rate constant, it was observed that suppose degrees of freedom is 10, but in order to get correct value, they have cut down half. That means there are 10 degrees of freedom, but in order to get the correct value, you have to use the 5. He could not extend it. Then three scientists, K, OK, Rice and Ramsey, they modified that equation on the basis of the statistical formula. But third scientist, Rice, Ramsey and Cassell, he introduced the quantum mechanics. Why quantum mechanics? Because we are talking about the energy. And you all know that E is equal to h nu, nu is equal to c by lambda. That is so. RRK theory is the combination of quantum mechanics as well as the statistical formula. He used K divided by K inverse 1 from the Singur equation. But for K2, he used simple statistical formula. And it's a new type of formula that K activated is equal to E minus E0 divided by E. Yes? But again, there was a problem that the frequency factor values are very high. Very high. He could not explain this thing. Then, in the same time, he stopped that theory, 1928. He stopped that theory. And he also derived two equations. One is called fast pressure. So, one is called high pressure and low pressure. High pressure is just like a Rani equation. He activated, and in low pressure there is no activation. He stopped that theory. Fortunately, Martha, as I told you that, just one minute, this is the quotation of Martha. I just want to see that quotation. Just 2 minutes.
Sir, degree of freedom that may be responsible for the structure of the compound.
Yes.
If the compound is linear, if the compound is
yes, they are definitely. But the problem is that I'm just talking about ER. I applied in 1948 to 6 well-theoreticians to the Martha's code. As I told you that he applied for postdoctoral fellow. I applied in 6 well-theoreticians for a postdoctoral researcher. The possibility that one of them might take an untested application. An application hardly qualified for theoretical. But too much to Oscar Rice at the University of North Carolina alone responded. And I blended the ideas from RRK theory 1920 with those transition state theory in the mid 1930s. What was published in 1991 generalization of the transition state theory, and he translated a loosely coupled harmonic oscillator. And in condition with that loosely coupled harmonic oscillator, the frequency may be different, but it is again the assumption that all these loosely coupled harmonic oscillator vibration of frequency is same. And as he told correctly that, but basically we are taking the unimolecular type of it. Most of the year parts. So degrees of freedom 2, 4, 50, like you can calculate which is Vn minus 6, you can calculate this. Sometimes 46, but actually not 46 degrees of freedom are responsible for chemical reaction. Out of that 46, only 20 or 15 are responsible. He actually identified that. Rotational and our hydration. And there are adiabatic and diabatic. Adiabatic means some kind of negative there is no change in quantum state or non-active. And second part is the active. So he categorically says, and then he applies for. So everywhere there are two derivatives. One is for high pressure and is for low pressure. I do not know what type of question we ask in your university like that. But in our cases, you have to derive for high pressure is different and a complete simple integration, differential calculus, integration by parts will be required. So at least 7 periods will be required. But my intention is that I am a motivational teacher. I use large number of inspire camp for the school students, for the college students, and as per the national education policy, now this system is there. And again I am saying that contextual understanding. So that after reading this whole unimolecular theory part, you are able to answer it. I do hope that at least you have a clear-cut idea about that you understand the Arnian situation, you are able to write the Gaussian theory, you are able to answer the accelerated complex theory. Similarly, if you understand the Riemann theory, you can very easily derive that theory, very easily derive the answer. Everywhere there is a long mathematical derivation. It is not at all difficult. Because you know that ultimately you get exponential x or x minus 1 factorial like that, gamma function. How many students are mathematics background? Gamma function, gamma function सब जगह gamma function है. Okay, gamma function है. 1 x minus 1 सब जगह x minus 1 factorial. Gamma function है. सब जगह gamma. Mathematics है. इसका मैं क्या किया? इसे motivational talk. That's it. A comprehensive information about the unimolecular. Okay. Due to this natural calamity, I must stop here and I am grateful to Rani Rashmoni University and particularly on Prof. Pandaka and Prof. because in our there is a central Bilaspur, 100 kilometers from Raipur, you are there. So I met him several times here. Very popular teacher, organic chemist. I will be here. And there are 13 universities in our small state. We are in IIT, we are in AIMS, National University, Triple IT, Agricultural University, Medical University. So I invite anytime you can visit. And most important that we organize all type of. I am involved in the Indian Chemical Society, then Indian Society for Surface Science and Technology, where Professor Panda is working. Another the world, India's largest society, and the joint secretary, Chemical Research Society of India. That N.R. Rao is the founder, and from July 2, 3 and 4, there is a contract in Indian Association for Fertilization. Again, I will come to US second So really it is a wonderful opportunity to interact with this. But of course, students are very there, and my past experience in West Bengal, I do deliver lectures in various places, but I really enjoy it. Because our time is very, very difficult. As for the N.R. Rao, 1 hour enough of brain required. 1 hour. More than 1 hour. Here, 1 घंटा 1 घंटा लीजिए and then come. Really, I think it's good. Rani Rashmoni, you know that, founder of the CSF. And a few days ago, it's a coincidence. I went to Joyramba. I went to Kallol K. And I Rani Rashmoni. Because my in-law, my wife, is water. I belong to in-law, parking in the all our parking. So thank you very much. join that meeting.
We are feeling sorry, sir. We are getting something at home. Yeah. Nice show. I hope you enjoyed it.